Hello! In this video, we will add a new node to our k3s cluster. In the previous videos, we prepared a simple Kubernetes environment, deployed a container which runs our CI/CD pipeline with the help of a build script. Finally, it deploys our application to Kubernetes. That's a really simple setup, so let's use it as a starting point and make it a bit more enterprise. We should solve high availability to respond to server failures and scale the system so it's resilient to increased load. Pod features means we have to add more nodes or pods. So let's install a new server. But I don't have hardware, that's why I set up a virtual machine. Download Ubuntu server, the newest version, and configure a new virtual machine. I use VirtualBox for proof of concepts on Windows, so just create a Linux 64-bit machine. Let's call it k3s node 2. Add a bit more RAM if you have. It will run multiple containers. Create a virtual disk. I don't know how big it will be in the end. I choose dynamically allocated disk. Let's check the settings. I enabled shared clipboard, disable drives I don't need, and add more CPUs. It's also a good idea if you plan to run containers. Then I mount my Ubuntu server live image, so I can boot it directly. Disable audio, network settings. It's a bit more complicated, because my master node is a physical server connected to my router. I want my virtual machine to connect directly to that network also. VirtualBox supports different network adapter types. For this setup, I will need a bridged adapter. Let's check how it works. Yes, that's it. My virtual machine will get an IP address from my router in the same subnet as my physical server. So change this to bridged network. I also disable USB ports. I don't need them. And we are ready. We can start up the machine. The server started up. It will start the installer. Let's use the newest one. Choose language, keyboard type, and default installation. You see that I get a proper IP address from my router. It's a good idea to use LVM if you plan to extend the disk later. If you are sure that you won't, you can disable it. I'm not sure if I don't extend it in the future, that's why I leave it enabled. We are done with the settings. The installation process starts now. Okay, so username and server name is needed. I will log in with SSH. Let's install OpenSSH server. As you can see, it's possible to install the server with Kubernetes, but we use a different implementation, so I will install it later. But Docker will be needed. This one we can install from here. Now we have to wait for the installer to finish. In the meantime, let's check how to add a new node to our k3s cluster. That's pretty simple. We have to install k3s and run this command. We need a token from our master node and its address. The server is ready. Let's try to log in. Great, we are there. Let's get root access and update the system. It's done. We should get the token from the master node. From this file. Okay, we don't have permission. Let's try as root. Fantastic. We have the token. To run this command, we have to install k3s first, in the same way as for our master node. Good, it went fine. Now run this command and start up the agent. Change the address to the master node and copy paste the token here. Something is listening on this port. That's another server which we started up after the installation. We have to stop it and run the command again. The k3s agent starts up. Okay, a lot of messages, some errors, but let's check if the master sees the new node in the cluster. Yes, it's there, and it's ready. That's great. Now we have a Kubernetes cluster with 2 nodes. If you stop it, it disappears. I would recommend a good interface for managing and visualizing Kubernetes workload. It's called Octant. It's free with a lot of features and nice interface. If you download and install it, it will use the Kubernetes configuration on your system. You don't have to configure anything. Our Hello World job is still deployed from an image from the local repository. You can generate or see the related configuration file immediately, delete or edit it from here. Let's check our nodes. Both of them are visible. The new one is not ready at the moment because I stopped it. You can see similar things with the help of this IDE plugin too, but Octant seems to be more advanced and straightforward. If you don't want to use another application and have everything in your IDE, it's fine. Okay, let's modify the source code to support this multi-node deployment. You can find the modified source code in GitHub. You can find the address in the description. Let's start with the deployment descriptor for Kubernetes. I compare the previous and the new version. We use a different kind here, not a job, but a deployment. I also changed the name, labels, not to confuse it with the previous deployment. The most important is now we want to have two replicas of this application. Now we have two nodes and one image repository on the master node. So we cannot use local repository on the second node. We have to specify also the IP address of the repository. But it means that we have to change the registry file for k3s, specify the IP address, and copy these settings to the second node too. And what about the demo application? The previous one started up, printed the message and finished. Now we want to run this application and see if it works on both nodes. Let's print more messages in an infinite cycle. The original message, hostname and timestamp every minute. Try to run this container and see the output. Good, that's what I expected. You also see the specific hostname of the Docker container. We should slightly modify our build script. As we implemented it as a general build script to build any similar projects, it's easy to modify it to build our new project. Just change the project variable. I also deleted the run section because the container would run and our build wouldn't finish. Great, I think we are ready. Let's redeploy our CI/CD container. The container started. We should wait for the build. It should start in a minute. The build process started up. Everything seems fine. We see both nodes. Let's check our deployment in Octant. Now we see two pods, one on our master node and one on the new one. This is what we wanted to achieve. Let's check the pods. This one is on the master node. You can see that it pulled the proper image, created a container and started it. I'm curious what we can see in the logs. Yes, this is the expected output. You can see now a k3s specific hostname. Okay, what about the second pod on the new server? It pulled the image, created a container, started it, but then it failed. We should check the logs. Maybe we can find useful information there. Yes, that's the problem. We built our image for Raspberry and it has a different architecture CPU type. This image cannot run on my processor in my workstation. It's a common problem for multi-architecture Kubernetes clusters. I will prepare a video about this later. For this exercise, it's enough that we see two nodes and two pods. We can play with this cluster. Great, but what happens when we shut down the second node? Well, you see, that the second node is not ready, but we want it to have two replicas. How can Kubernetes fulfill this request? As you can see, the deployment is healthy, green, because it has two pods, but on the same server. The cluster lost the second node. That pod doesn't work, it will be deleted. But in the meantime, Kubernetes started up another pod on the same server. And what will happen when we start our second node again? Let's figure it out. Start the agent again. And you see that we still have two pods, but on the same node. The cluster is not rebalanced, and it won't be, because the deployment request is fulfilled, it has two pods. To rebalance the cluster, you can set up a job or add more configuration to your deployment description. Or you can simply delete a pod and Kubernetes will deploy a new pod on the second server to balance the cluster. You see, the new pod was created almost immediately. And that's all. We added a new node to our cluster successfully. Thank you for watching. Please subscribe if you are interested in such quick and simple tutorials.